It's the dead of winter. The land lies cold and empty, the fields bare after 3 years of failed harvests. Grain has rotted where it grew. Along the muddy roads, the bodies of the starving mark the path of a continent in collapse. Entire villages vanish from the map. Yet in a few scattered communities, people survive. Not because they are richer, stronger, or luckier, but because something hidden in their biology gives them access to a food source others can't touch. While their neighbors waste away, these survivors turn to the one thing that still flows fresh, even when the earth gives nothing back: milk. From their cattle, huddled in barns against the endless rain, comes a steady trickle of life, warm, calorie-rich, and miraculously renewable. This is the story of how a single genetic mutation changed the fate of an entire continent, and how milk helped shape the survival of Europe itself. If you enjoy uncovering the hidden science behind human history, consider subscribing for more stories like this. Around 7,500 years ago, somewhere in ancient Europe, a tiny typo appeared in the DNA of a few individuals, a single mutation in a gene called LCT. This change had one crucial effect. It kept their bodies producing an enzyme called lactase, the molecular key that breaks down the sugar in milk. For most humans, that switch turns off after early childhood. Once weaned, the body stops wasting energy on digesting milk. But for this small group, the switch jammed in the on position. They could drink milk for life. That microscopic difference meant survival. When crops failed or winters dragged on, they had a steady source of calories and protein. And over generations, nature rewarded them for it. For most of human history, being lactose intolerant wasn't a flaw, it was normal. Every baby is born with lactase, the enzyme that unlocks the sugars in milk. But after weaning, the gene usually switches off. Without lactase, lactose becomes a burden. Bacteria in the gut feast on it, releasing gas, causing cramps, and sending the body into distress. Today, about 65% of people worldwide still follow that ancient pattern. In much of Asia, Africa, and South America, a glass of milk means discomfort. But in Northern Europe, the script flipped. Nearly everyone can drink it without a problem. Around 9,000 years ago, waves of farmers from the Fertile Crescent began spreading across Europe. They brought seeds, tools, and livestock, sheep, goats, and cattle that could turn grass into nourishment. For the first time, humans were milking animals. But there was a catch. Most of them couldn't drink what they produced. Milk was rich in energy, but for the majority, it led to pain and sickness. So they fermented it into cheese and yogurt, reducing the lactose and making it tolerable. Dairy farming came first. The genes followed later. Once milk became part of the diet, nature had a new challenge to solve: who could actually digest it? About 5,000 years ago, a new force swept across Europe from the vast grasslands of what is now Ukraine and southern Russia, the Yamna or Yamnaya people. They were herders, not farmers, moving with their cattle across the open steppe. Milk wasn't a luxury to them. It was their lifeblood. Genetic studies show that the Yamna carried extraordinarily high levels of the lactase persistence mutation. When they migrated west, they didn't just bring horses and wagons, they brought this powerful genetic advantage. As they settled and interbred with Europe's early farmers, their DNA spread like wildfire. Those who could thrive on dairy grew stronger, survived harsh winters, and had more children. Within a few thousand years, the ability to drink milk had transformed from a rare quirk into one of Europe's defining genetic traits. Milk changed everything. It was food security in liquid form, a steady supply of calories, fat, and protein, even when crops failed or winters dragged on. Cows and goats turned grass into nutrition, and humans learned to turn milk into a dozen other foods: butter, yogurt, cheese. Archaeologists have uncovered the physical traces of this transformation. Across prehistoric Europe, pottery vessels appear with tiny perforations, early cheese strainers. Clay jars still carry molecular residues of milk fats absorbed into their walls thousands of years ago. These weren't simple cooking pots. They were the specialized tools of a new economy. This dairy revolution allowed communities to store food longer, feed more people, and survive in harsher climates. It also laid the foundation for Europe's culinary identity. From creamy butter in Scandinavia to aged cheeses in France and the Alps, these traditions trace back to the moment humans turned survival into cuisine. The milk gene didn't spread evenly across Europe. In the north, Britain, Scandinavia, the Netherlands, nearly everyone today can digest lactose. But farther south, in places like Italy, Greece, and Spain, as many as half the population can't. Climate shaped this divide. In the north, long winters and short growing seasons made reliable food scarce. Milk became a lifeline. In the Mediterranean, milder weather and longer harvests reduced that pressure. There, crops and fruits provided year-round nourishment, and the genetic advantage of milk mattered less. A few exceptions tell deeper stories. Islands like Sardinia or regions of the Balkans show surprisingly low rates of lactase persistence, reminders of how isolation and limited migration left pockets of old genetics untouched. The rise of milk wasn't just a genetic story. It was cultural evolution in motion. Humans didn't wait for biology to catch up. They found ways to make milk work. Fermentation, cheese-making, and butter churning turned a fragile, perishable liquid into safe, long-lasting food. Culture and genetics began to reinforce each other. Those who could digest milk gained strength. Those who couldn't still benefited through clever processing. Over time, natural selection amplified the advantage, spreading the lactase persistence mutation faster than almost any other in human history. And this wasn't unique to Europe. Across East Africa and the Arabian Peninsula, entirely different mutations appeared, distinct genetic solutions to the same survival challenge. Everywhere dairy animals thrived, evolution followed. Today, the genetic gift that once saved lives shapes entire economies. Northern Europe's major dairy nations, the Netherlands, Ireland, Denmark, Switzerland, owe part of their prosperity to that ancient mutation. Milk is no longer just survival, it's industry, culture, and comfort. Every café latte, every wheel of cheese, every splash of cream in morning coffee carries echoes of prehistoric adaptation. What began as a desperate evolutionary edge became a cornerstone of European identity. Our ancestors' ability to digest milk didn't just feed them. It built the foundations of diets, cuisines, and even global trade that endure to this day. All of this, centuries of survival, migration, and culture, traces back to one molecular flicker in human DNA. A single on switch in the LCT gene allowed a few ancient Europeans to drink milk without pain, and that tiny advantage rippled through millennia. It reminds us that evolution doesn't always shout. Sometimes it whispers through generations, hidden in our everyday habits. The milk in your glass isn't just food, it's history written in your body. A mutation once meant life or death. Today, it's breakfast. If you enjoyed this story and want more deep dives into how our genes shaped our world, don't forget to subscribe for future videos.